This videotape deals with rules for working with exponents. In an earlier tape, we considered the problem of multiplying x to the third power by x to the fifth power. If you'll recall, x to the third power meant x written as a factor 3 times. X to the fifth power, of course, x multiplied by itself 5 times. And the natural answer to this problem would be, since you have x to the third power times x to the fifth problem, you would get x to the 8th power. Okay, you have 3 x's here, 5 of them there all together. X times itself 8 times x to the 8th power. Okay, and we formulated this as a first rule for exponents. Okay, rule number 1. A to the m power times a to the n power is a to the m plus n power, where m and n are positive integers. A can be any number here. In other words, instead of actually writing down x times itself 3 times and x is a factor 5 times here and counting it up and getting x to the 8th, we can say x to the third power times x to the fifth power is x to the 3 plus 5 power, or x to the 8th power. In other words, when the base is the same, okay, here we have the base x, the power is 3. Here the base is x, the power is 5. When you want to multiply, okay, and in both cases the base is the same, you keep that base and you add the powers. Okay, so you get x to the 3 plus 5, or x to the 8th power. Okay, let's try another example. If you have x squared times x to the third, okay, this would be x to the 2 plus 3, or x to the 5th power. You keep the base x and you add the powers. Of course, this is x times x, this is x times x times x, for a total of 5 x's there, with x to the 5th power. Okay, now what if we had 2 to the second power times 2 to the third power? Okay, the base is 2. The same base occurs in both of these. We keep the base, we add the powers, we get 2 to the 5th power. Okay, remember, 2 squared times 2 cubed is not equal to 4 to the 5th power. Okay, now nobody would do that with x. Everybody knows you keep the x, you add the powers, you get x to the 5th. But somehow when you see numbers, sometimes people get confused and they're multiplying, and not only do they want to add the powers, they want to multiply the bases as well. That's not what you should do. You keep the base 2 and you add the powers. Remember, 2 squared is really 4. It's 2 times 2. 2 cubed is 8. 4 times 8, that's 32. That's 2 to the 5th power. 4 to the 5th would be way too large here. Okay, so don't multiply the bases. Keep the base and add the powers. This is not the way to do it. That is. Okay, so this is our first rule for exponents. When you're multiplying and you have the same base, you keep the base and you add the powers. Let's consider a second rule for exponents. Okay, we'll start with an example. Let's say you want to divide x to the 7th divided by x to the 3rd. Okay, now x to the 7th would be x times itself 7 times. We'd have x, 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 divided by x cubed, x times x times x. Okay, and when you cancel these 3 x's out here and here, divide numerator and denominator by x cubed, you notice that you're left with just x times itself 4 times, or x to the 4th. So x to the 7th over x to the 3rd comes out equal to x to the 4th. Okay, you might notice a certain relationship. If you were to take 7, take away 3, you would get 4. And that is, in fact, the second rule for exponents. If you have a to the m power over a to the n power, it's a to the m minus n power. Okay, when you're multiplying, okay, you add the exponents. But when you're dividing, you have the same base here and you're dividing, you keep the base, you subtract the powers. X to the 7th over x to the 3rd is x to the 7 minus 3, or x to the 4th power. Okay, now for the time being, I'm going to restrict this to m and n being positive integers and m greater than n. Okay, this will be relaxed in a future videotape. Right now, we want m greater than n because, for example, if m is equal to n, we'd have 0 up here and a 0 power we haven't considered yet. And if m is less than n, the power would be negative. So for the time being, we don't want to consider that. We will discuss that in a future videotape. Right now, we are restricting this to m greater than n. In fact, m and n positive integers. Okay, let's try another example using that. Okay, let's work out x to the 5th over x to the 3rd. Okay, this would be, now of course you could multiply x by its, write it down x times itself 5 times and divide by x times itself 3 times and be left with 2 x's in the numerator for x squared. But I would prefer you to say it's x to the 5 minus 3 or x to the 2nd power. Okay, you can imagine the difficulty if you were going to handle, say, x to the 120th power, okay, over x squared. You don't want to write down x times itself 120 times and then divide by x squared. It's easier to say simply x to the 120 minus 2 or x to the 118th power. Okay, let's consider an example which combines the first 2 rules for exponents. Okay, let's say we want to handle x to the 4th times x to the 2nd divided by x to the 3rd. Okay, you can first use the, well, you can start with the first rule for exponents on the top. X to the 4th times x squared. You're multiplying. You keep the base x. You add the powers 4 plus 2 to get x to the 6th. So you have x to the 6th over x cubed. Okay, it's x to the 4th times x to the 2nd. That's x to the 4 plus 2 or x to the 6th. Now dividing by x cubed, we use the second rule for exponents. X to the 6th over x to the 3rd is x to the 6 minus 3 for a final answer of x cubed. Okay, now let's consider an example. Let's say we wanted to take x squared and raise that to the 3rd power. We have like a power to a power here. X squared cubed. Let's try to reason this out. If we have x squared cubed, that means we have x squared times itself 3 times here. X squared times x squared times x squared. And of course, x squared is just x times x. And our end result is x times itself 6 times for an answer of x to the 6th power. And you will notice that what we really did here is just multiply these 2 powers together. Okay, and that gives us rule 3 for working with exponents. A to the m power raised to the nth power. A to the m to the n is simply a to the mn. Okay, now please keep this straight in your mind. If you have x to the 5th times x squared, that's not the same problem as x to the 5th quantity squared. X to the 5th times x to the 2nd, okay? This is the first rule for exponents. We're multiplying. The base is the same. We keep the base x. We add the powers, 5 plus 2 to get 7. This, however, is the third rule for exponents. A to the m to the n, okay? Notice that here the base appears twice, and it's a multiplication. Here there's only one base in like 2 powers. Okay? We keep the base, and we multiply the powers, 5 times 2 giving us 10. This is the first rule for exponents. This is the third rule for exponents. X to the 5th times x to the 2nd is x to the 5 plus 2 or x to the 7th power. x to the 5th squared is x to the 10th. You multiply the powers. When the powers appear next to each other with no other base in there, then you're just going to be multiplying these powers. Let's consider an example which combines this third rule for exponents with the first rule. Let's work out x squared cubed times x to the 4th. Okay, now the third rule for exponents that we just worked out tells us that x squared cubed is x to the 6th power. In other words, you multiply the powers. That's not x squared times x to the 3rd. Okay, this is x squared cubed. That's x to the 6th times x to the 4th. Then we use the first rule for exponents, x to the 6th times x to the 4th, giving us x to the 10th power, keeping the base and adding the powers. Here we multiplied the powers. This was a to the m to the n. This was rule 3. We multiplied the powers. Here we use rule 1. We keep the base and we add the powers. And the answer is x to the 10th. Okay, now let's consider something like ab to the 3rd power. Okay, ab to the 3rd power means logically ab times itself 3 times. Okay, now you can reorganize this product here using the associative and commutative laws for multiplication to get a times b, which is, of course, a cubed, b cubed. Okay, notice this. We have ab, a product to a power. And what we got was each factor raised to that power. ab cubed is a cubed, b cubed. And this gives us the 4th rule for working with exponents. ab to the nth power is a to the nth power times b to the nth power. Once again, the power here we're talking about is a positive integer, but this will later on be relaxed. And also, although you can logically reason it out in a problem like this, if you were working out something more complicated, for example, ab to the 300th power, nobody wants to write ab times itself 300 times. Okay, it's good to have rules to fall back on. And especially when we get to negative exponents later on, it's very handy if you know the rules cold. Okay, let's try an example of this rule. Say we have 4a to the 3rd power. Okay, this is a product to a power. We're going to take each factor to that power. It's like ab to the nth power. It's going to be times a cubed. Now 4 cubed is 4 times 4 times 4. 4 times 4 is 16 times 4, that's 64 a cubed. If you want to try any of these on your own, you can shut off the videotape machine and turn it back on after you've completed the problem. Okay, 2x squared y cubed to the 4th power divided by 8x cubed squared y to the 5th. Okay, the first thing I'm going to do is to use rule 4 we just had. That was for a product to a power. Okay, we have it's sort of like a, b, c to the nth power, but that rule can be extended for more than 2 factors. We're going to raise each factor to that power. So we'll have 2 to the 4th power x squared to the 4th power y cubed to the 4th power over, now the whole numerator was to the 4th power, so we broke it up. 2 to the 4th, x squared to the 4th, y cubed to the 4th. The denominator doesn't have that. We have 8 by itself, x cubed to the 2nd, and y to the 5th. Okay. 2 to the 4th, x squared to the 4th, y cubed to the 4th, over 8, x cubed to the 2nd, y to the 5th. Now we're going to make use of the rule for exponents that said a to the m to the n is a to the mn. That was the third rule. Okay, we're going to use it 3 times, here, here, and here. In each case, we have a power to a power. Okay, this is going to give us, well, 2 to the 4th we'll leave alone right now. X squared to the 4th, that's x to the 8th. Y cubed to the 4th is y to the 12th over 8. X cubed squared is x to the 6th power, and then y to the 5th. Each case, when we have a power to a power, I multiply the powers. 2 times 4 for the 8, 3 times 4 for the 12, 3 times 2 for the 6. Okay, what I'm going to do now is break this up into 3 fractions. I'm going to work them out separately. By the way, 2 to the 4th is 16. It's 2 times 2, that's 4 times 2, 8 times 2, 16. Okay, I'm going to break this up into 16 over 8 times x to the 8th over x to the 6th times y to the 12th over y to the 5th. Okay, this is, of course, equal to that. You can multiply, to multiply fractions, you multiply the tops and divide by the product of their bottoms. Okay, so we have the exact same thing. It's just going to be a little easier to understand it in this way. Now, first let's worry about the constants here. 16 divided by 8, that's just going to give us 2, or 2 over 1. X to the 8th over x to the 6th using the second rule for exponents. When you divide, you subtract, of course. You have x to the 8 minus 6 power, and here y to the 12 minus 5 power, for a final answer of 2 x squared y to the 7th power. And now I'm going to give you one more rule for exponents, and it's going to cover a situation like this. When you have a fraction, say x over y, raised to a power. By the way, in all of my fractions, I'm always assuming that the denominator is not 0, okay, so that the fraction makes sense. Now, if you have a fraction to a power, well, it means, in this case, this fraction times itself 4 times. X over y times x over y times x over y times x over y. And since to multiply fractions, you multiply their numerators and divide by the product of the denominators, we have on the top x times itself 4 times, or x to the 4th, and on the bottom y times itself 4 times, or y to the 4th. So from this we get that it seems when you take a fraction to a power, you take the numerator to the power and divide by the denominator to that power. And that is, in fact, Rule 5. If you have a over b, a fraction to the nth power, once again assuming that the denominator is not 0, it's going to be the numerator to that power, a to the n, divided by the denominator to that power. And this is similar to the rule we had for products. A product to a power, okay, you take each factor to that power and multiply it together. A fraction to a power, it's the top to the power divided by the bottom to that power. In the problem that we're working out now, x squared y cubed to the 2nd power all over x cubed y. Okay, notice the difference. They both involve fractions, but here it's the whole fraction to a power. That's Rule 5. In other words, it's the top to the power over the bottom to the power. The whole fraction is being raised to the power. Here there's a fraction, but only the top is being raised to the power. So we do not use Rule 5 on this case, in this problem. Now, We will use Rule 4, which gives us, we have a product to a power. We'll take each factor to that power. X squared squared y cubed squared over now x cubed y. And x squared squared, of course, is x to the 4th power. Y cubed squared is y to the 6th power, multiplying the powers together, over x cubed y. Okay, and this can be broken up into x to the 4th over x cubed times y to the 6th over y. Y, of course, is y to the 1st power. Don't forget that. So we can break it up like this. X to the 4th over x cubed is x to the 4 minus 3 power. Y to the 6th over y, or y to the 1st, is y to the 6 minus 1 power, giving us a final answer of x y to the 5th. Before finishing this videotape, I just want to point something out. I gave you a rule for a b to the nth power, which is a to the nth power, b to the nth power. In other words, a product to a power. You take each factor and raise it to that power, and you multiply them together. I did not give you a rule for a plus b to the nth power. This is not a to the n plus b to the n. Okay, many people wish it were, but it's not. Okay, let me give you an example illustrating why this one works and this one doesn't. Let's consider the numerator of the last example that we worked out. Okay, we had x squared y cubed. It was to the 2nd power. This, according to the rules of exponents, would be x squared squared y cubed squared, which was x to the 4th y to the 6th. Now, if it were instead x squared plus y cubed squared, you could not say that that is x to the 4th plus y to the 6th. Don't forget what you already know to be true. In other words, this is not, you don't send the power through that way, only when it's a product. It's not x to the 4th plus y to the 6th. We all know that this is really x squared plus y cubed times x squared plus y cubed. We could work this out by the FOIL method because we're multiplying 2 terms by 2 terms. In other words, we multiply the first terms together to get x to the 4th. X squared times x squared is x to the 4th. The outer terms gives us x squared y cubed. The inner terms also gives us x squared, so we have 2 of those. And in the last terms, y cubed times y cubed gives you y to the 6th. Okay, so we have not x to the 4th plus y to the 6th, but x to the 4th plus 2x squared y cubed plus y to the 6th. Okay, there's no shortcut. Okay, and it gets even more difficult. For example, if this was x squared y cubed to the 12th power, you could make it x squared to the 12th, y cubed to the 12th, and just work it out the same way. But x squared plus y cubed to the 12th power would have to be done by a long multiplication. Okay, x squared plus y cubed times itself 12 times. It's no fun, but that's the way you have to do it. Okay, and that brings us to the end of this tape.